Hello, this is Coach Mower for AP Pre-Calculus sections 4.10, 4.11. We're just cramming all this matrices stuff in here. So let's get rocking and rolling so you can learn what a matrice is. So a matrix is a rectangular arrangement of numbers in rows and columns. Matrix can be representations of equations, vectors, or linear applications. A matrix dimensions are expressed by rows by column. So for this first example right here, not example, but just a little bit of a, hey, what's the point of a matrice? It's because we're so lazy of writing equations. We can just write it, instead of the x's and the y's and the equals, we can just write it as a matrice. So this is an example right here. This 2, 1, 4 on top as the row, and then the 5, negative 3, 1 can represent the system of equations to the left. If you notice, all the coefficients coincide there. And we know this is a 2 by 3 matrix because we have 2 rows. So rows and then columns, 3 columns. Okay. So some simple operations here. What's the matrix addition and subtraction? All you're going to do is just add the corresponding elements together. So the upper left one is going to be 1 plus 6, which is 7. The upper right one is 2 plus negative 7, which is negative 5. Lower left is going to be 3 plus negative 2, which is 1. And then lower right is going to be 4 plus 5, which is 9. And we can only add matrices that have the same dimension. So the same rows by same columns. Okay. Matrix with a scalar multiplication. We just call it scalar because we're just going to multiply it in front. If you ever see something like this, let's always write everything inside the matrix as our final answer and nothing left on the outside. So if I multiply all these by 4, this is going to give me 4. Oops. Just rewrite that again. Give me 4, negative 8. Oh, we are struggling today. Maybe I got it here. Negative 8. Yeah, that 4 even looks a little whacked out. Let's change that. All right, so 4, negative 8, 28, ooh, and 0. There we go. Okay. Multiplying a matrix by a matrix, this is where we start to get a little confusing here. So we can only multiply matrices if they match up a certain size. So for A, if it's m by n, and then B is n by p, then it's going to produce a m by p matrice. So I kind of do a little bit of a paragraph right below that with everything. But really, the bottom left picture is what we need to do. So if you notice on this one, we have a 3 by 2. Okay, or sorry, 2 by 3. And then we're multiplying this by a 3 rows by 2 columns. Oh boy. Okay, so we can do that because the 3's on the inside match up, and it's going to produce a 2 by 2, as you can see. It does below. So the highlighted sections are really, really important for us. So that's the top row times the left column produces the upper left of 140, and so on and so forth. So I'm going to go through this. I can tell that my computer is glitching a little bit, and so this is going to make this really, really fun. All right, I'm going to just kind of highlight what I'm doing and go in that process as I'm highlighting. So I'm going to first do the top row with the left-hand side, and this is a 3 by 2 and a 2 by 3. No, hold on, 2 by 3. I know what it is. I'm just not saying it right. This is a 2 rows by 3. Oh boy. And this is a 3 rows by 2 columns. This is going to produce a 2 by 2. So our final answer is going to be a 2 by 2. So with what I just highlighted, I'm going to do 2 times 0. This is going to be a long one if I can't write this down. 2 times 0 plus negative 1 times negative 1. Plus 5 times 1. I'll solve that part in just a minute here. So that's our first part that I highlighted. Now let's go ahead and do the upper row right-hand side that can produce my upper right. So that's going to be 2 times 6, negative 1. We're adding these components together. Negative 1 times 4 plus 5 times 2. And then we're now going to do the bottom on the right, on the actually left side. We'll start with this one. It looks weird, but whatever. So we're going to get 1 times 0 plus 0 times negative 1. How did that happen? It's going to be a long video if it keeps acting up. Plus 4 times 2. Or sorry, 4 times 1. Okay. And then my final one I'm going to highlight here is going to be the bottom. I guess I just have the bottom highlighted. Bottom and the right hand. So what the heck? It's not me. So this is going to be 6 times 1 plus 0 times 4 plus 4 times 2. And this is going to equal, put everything on the top right there. So we're going to get 0 plus 1 plus 5. I got 6. Upper right-hand one, I got 18. And I'm going to get 4 on the bottom left. And then I'm going to get 14 on the bottom right. Okay, so there you go. Matrices multiplication. Ooh. Don't know why I did that. It was not spooky. All right. Zooming out a bit here. All right. Next page here, identity matrix. Identity matrix, I have a bunch of examples what those are on the right-hand side, but they're just square matrices with just ones that are across. So the corners going diagonal are ones. Everything else is a 0. It's known as an identity matrix. It means that when you do multiplication, you will get a similar matrices. So for this one, for A times B, B is an identity matrix. It's an I sub 2 because it's a 2 by 2 identity matrix. So this is 2 by 2 times 2 by 2, which I can do a 2 by 2 times 2 by 2 produces a 2 by 2. So I'll write up here 2 by 2. This is a 2 by 2. Since the middle ones match, it's going to produce use the outer ones 2 by 2. So when I do this, I'm going to do 2 times 1. And plus negative 3 times 0. Because that is the top row. I'll highlight what I just did. So that's that part right there. What I just wrote, that's that part right there. Okay, now I'm going to do this part now, which is going to be 2 times 0 plus negative 3 times 1. In the bottom left, it's going to be bottom one that way. And we're going to go that way. This is going to give me negative 1 times negative 1. Or sorry, negative 1 times 1. Plus 4 times 0. And then if I change it up now, I'm looking at this one. It's going to be negative 1 times 0 plus 4 times 1. When I do this, I do end up with 2, negative 3, negative 1, and 4. So you multiply that by the identity matrix, you'll get the same thing. Oh, what the heck just happened? My computer's going nuts. Okay. Okay, last little thing here is inverses. So when a new matrix is multiplied by the given matrix results in the identity matrix. In other words, that produces that's what the inverse is. So to define the inverse, we're going to first learn what a determinant is. Determinant is when just a 2 by 2, there's two determinants are 3 by 3. Those get more confusing. We're just going to do 2 by 2s only in this class, is when you multiply the corners by each other. So the top left, bottom right multiplied, subtract the bottom left, top right, and that produces the determinant. So to solve for the inverse matrix, you would just do 1 over the determinant, and then you just swap the corners, and then you negate the opposite corner. So you swap the top left, bottom right, and you negate the bottom left, top right. Probably seems a little confusing. It's easier to just use the formulas here just to kind of go through it. And again, the whole point is if you were to multiply the original matrix by its inverse, it will produce the identity matrix. Okay. So what we're going to do here is we're going to determine the find the determinant of this. And actually, I'm going to add in, I forgot to add this in. And we're going to find a to the negative 1. Okay, so we're going to do 2 things here. Forgot to add those directions in, but whatever. Okay, so find this determinant first. The determinant of A. Zoom in here. So the determinant of A is going to be when I multiply the diagonals by each other. So I'm going to do 2 times 4 minus, all right, because it's a minus sign up here, determinant, you can see it right in the middle, minus, I'll erase this now, these diagonals being multiplied, so it's going to be negative 1 times negative 3. So you're going to get 8 minus 4, which is just 4. Okay, so to find the inverse, it's going to be 1 over the determinant, so it's 1 over 4. And then we swap the top left, bottom right. So it's going to turn into a 4 there, 2 there, and then we negate these. That's it. And let's go ahead and distribute that 1/4 in there. So we have a nice, pretty matrix of 1, 3/4, 1/4, and 1/2. Ooh, that 1/4 looks a little messed up. There you go. There's the identity. So if you're going to multiply A inverse and A together, you should get the identity matrix. I will not do that, but if you want to try that out on your own, feel free. All right, last thing here is just another application of the determinants. What we're going to do here is to find the area of a parallelogram. It's not really written in the notes. I'll just kind of tell you how to do it. You're going to find these 2 matrices. So I'll call one A and one B. All we're going to do is find the determinant of these 2 vectors. So vector A from the origin is going to be, it looks like it goes over 2. So it's, remember, it's head minus tail. Tail is just 0. So 0, 0. So 2, and this should be 5. And then B is going to be 4, 3. Okay, so what we're going to do now is create a matrix from this. I'm going to put this as, actually, it does not matter which way we do it. I'm going to just put this as columns. So let's rewrite vectors as columns. So this is going to be 2, 5, and 4, 3. So you can kind of see how like A is right here, B is right there. Okay, and then let's find the determinant. I'll call this A, just so we have a name for it. And then so the area is going to be equal to the determinant of A. So that's our applications of this. Sorry, is the absolute value. I was going to say, I want to get negative. It's the absolute value of the determinant. So here we go. It's going to be 2 times 3, absolute value of 2 times 3 minus 5 times 4, which is 6 minus 20, which is a positive 14 when you take the absolute value of that. So 14, I don't have any units, so I'll just keep it as that. So there you go. There's an application of matrices and determinants and how they can be used geometrically. And that's going to wrap up here our little set of notes here on matrices. Do not forget to like and subscribe.